Welcome back. In this video, we're going to go over one of the problems that we ran into in our last video, namely a context length problem. The context window that the LLMs are assigned, whether by default in Ollama, the model itself, resetting the context window in Fabric so that things work properly, knowing what kind of context length you even are going to need before running a command instead of wildly guessing. These are all things that can be solved in a pretty direct way. One of the problems that we had was getting a proper response from Extract Wisdom. So we'll just grab the URL to the Fabric video by Miesler and we'll get to it. So you can see as we're running the command, we get this from Extract Wisdom. We expect something much more analytical of what's being passed to it, which is the nearly half-hour transcript from the Miesler video on Fabric. And we solved that by running the same command, but we extended the context window by approximately doubling it. Now, the default context length is likely to be 8,192 or something like that. And so to technically double it, it would be 16,384, something like that. I'm not that great at doing math very quick in my head, but it's a little more, but 16,000, you can set exact amounts. So this would solve the problem, as we'll see. And right away we can tell because we're seeing the summary ideas and the markdown format and knowing the contents of the Extract Wisdom pattern. So this is the problem. Now, how do we know? How are we to even guess at what the context length should be? And how do we know that the bug is in the Fabric tool sending the Miesler Fabric transcript twice? How do we know that these things are true? How do we know what we're getting into? Well, we'll just run the dry run command on just the YouTube transcript again, and we see we have, to be sure, we have the transcript once, and it's quite a bit of text. Then we run it again with what the full command would have been, which the command would look like this. And as we scroll up, there's the beginning of the transcript once. Hey, what's up? My name is Daniel Miesler. And then scrolling up the top, we see it again. Hey, what's up? My name is Daniel Miesler. And then the Fabric Extract Wisdom pattern. And then this is where we ran the command. So unless the bug is the dry run not correctly reporting and saying that the Fabric tool is sending the transcript twice, or the bug is that the Fabric tool is sending the transcript twice. So how can we check that without going all over the internet and everything like that? Well, one way that we can check it is I made a tool real quick in Python that can check the token count of anything that you pass to it. And I just called it token counter. And we can pass to it sentence or the body of text. How many is this? All right. I have the tool. That's the hyphen, not the underscore. And so that's 5 tokens. How many is this? That's 5 tokens is what it would be counted as sent to an LLM regarding the context window. The context window being the number of tokens it can handle in one payload back and forth. And how accurate is this? Well, you'll see at the end of this video, we're going to build the tool on our system real quick, and it'll be a standalone executable. And real quick, this is a OpenAI tokenizer count. There is a Llama tokenizer counter, a method of doing it using the transformers library in Python. The GPT counter here uses the tick token, I think is the name of it. We'll see when we get into the code. And it's very, very simple to set up and build. And Llama token counts are slightly longer. This, how many is this question, where the OpenAI token count on it, which means how many tokens is it for a GPT model, is 5, and using a Llama model of any sort, which also would mean Mistral and a whole bunch of others. And we're just trying to roughly get this token count. We don't need exacts. We just need to know what we need to set our model context window to when we're running something. If we know that it's long, we want to have a rough idea of what we're dealing with here. So that's all we're trying to do is get a rough estimate, and then we just go over that by however many couple thousand tokens or whatever we want or expect the length of our response from the LLM to be. We want our context window to be at least roughly what we're sending to it plus roughly what we expect from it, and then a few extra 1,000 tokens. So a Llama tokenizer count is going to be slightly more. So where the GPT or the OpenAI counter puts this at 5 tokens, a Llama counter might put this at 6 or 7 tokens maybe, because it has to do with the way they deal with punctuation and break up some of the words into tokens. So So we don't really need to get more technical than that for what we're doing now. So this is just showing you how the token counter works. So if we were to run, say, this guy right here, and I have the token counter built so that you can pass it something directly in line, or you can pipe to it, just like you do it with the Fabric tool and so many other things. So, and you'll see the way that I built it real fast. It's very, very simple. So here we would just put in token counter, and hopefully this works. So the transcript for this nearly 30-minute YouTube video from Miesler, according to an OpenAI token counter, is 4,840 tokens. That's about that's a little more than half of our default context window with a llama model and many, many others. The Ollama, I think, tends to set the default context window around that 8,192, roughly 8,000 plus token context window. And so if we're correct in saying, and if I'm correct in thinking that the Fabric tool is sending the transcript body twice, that would very easily put us over the default context window of 8,000 plus tokens. And what it does when that happens is it takes the last of the context window value. So if this is 4,800, let's say, then doubling that by doubling the transcript and sending it to the LLM puts us at like 9,600 tokens. So it would take the last of those 8,000 plus tokens, and the Fabric pattern extract wisdom would probably be left off. And that's why, thus now not having the Fabric pattern as an instruction set in the system message, the system message might be getting emptied out, and all that the LLM is seeing is, even though it's duplicated one full time, it's just seeing the transcript. And so the model is probably defaulting to its own system message, which is to be a helpful assistant or whatever. It's just going to assume something like you wanting a summary, a very quick summary of the transcript instead of the extract wisdom details that we're wanting to get out of it. That's most likely what's happening here, if I'm right on the transcript being sent twice by the Fabric tool. And so what we can do is take a look at this command right here, which would actually send, the tool would send everything. And we'll try right now, we'll try and pipe this to the token counter. The 265, this command doesn't work. The 265 is the tokens from the response from extract wisdom. So what we need to do is leave the dry run in there. So here we have Fabric pulling the YouTube transcript, converting it, to local text, piping that to the Fabric command, and then the Fabric command running extract wisdom on the body of text that we're sending it, the YouTube transcript, converting it to a dry run, which is just spitting out into the window everything it would send, and then we're tokenizing, we're doing a token count on that body of text, and we'll see if this gives us, so it's more than 9,600, it's about 10,000 tokens that we're sending with this command right here, is sending a little over 10,000 tokens to a model that is defaulting to 8,000 plus tokens. And that's why, after resetting and probably ejecting the system message, which is the extract wisdom pattern, that's why we're not getting the extract wisdom response that we expect. That's exactly what's happening. I believe that's exactly or precisely what is happening. So one thing that would be really cool is if one day, say we sent anything, some body of text, this anything means nothing, this would kick an error, but just this anything representing whatever we're sending it to the Fabric command, and as a dry run, it would be really cool if one day they added on to the dry run having a dry run tokens telling us this count by adding some kind of functionality. It would have to be in Go. And we can actually probably figure this out using extensions that are built in that you can build out for the Fabric tool. And that's down the road just a little bit. Extensions are some of the last things that we're going to get into. This doesn't exist, but it would be nice if it did. So what we want to do now that you've seen exactly what I believe to be happening, it's not the focus of this video to really beat to death what's happening with the context problem here that we're running into, because it's pretty simple. You just elongate the model context, and you could even go into the setup menu. And when you set the default model, say we type 13, we could press enter to leave the model that we have if that's what we want. And then right here, we can reset the model context length for everything that we run on it. We could put in 16,000 here, and that would always have the context window being 16,000. Now, it slows down inference, a little bit. And so if that's not something you want to do, if you want to leave the default context window at the 8,000 plus and just just extend the context length when you need it, when you know you're going to need it, then we would want to build this token counter tool that I've built. That was pretty bizarre that it responded to that. Help us out, Fabric. I'm not even gonna take no idea how that just happened, because the token counter is not hooked up to an LLM. It's a very static and very tiny Python script. I'll look into that one day. Boy, that's pretty funny, actually. So at any rate, to build this tool, where I put this tool is in the .local bin, which you'll remember if you think back to installing the Fabric binaries and either aliasing them or putting them in our path in order to not have to type /. And I put the token counter right here. And to go through the process of building it again, I'm going to delete that. My token counter has just been garbaggioed. Now, so in this bin directory here, the .local bin, in this bin directory, I just made a directory in the command line. I'll drop out a Ranger to show you this. I made this token counting directory just by running the make dir command, typing that out. And then if we cd into that, you'll see we have a few things. Now, this was left over from the build. So I'm going to remove that just so that no one gets confused about anything at all. And I'm going to delete that build directory too. So all we have are these two files. I just deleted everything so that we just have these two files, because these are what we're going to want to look at. That's all we have. To understand how to build this thing, it's not very complex. We're using Python to make it super easy. We just need to make a virtual environment. And in Ubuntu, this is how you do it. I follow the convention of naming virtual environments. So venv is what I always do, so that when you go into the directory where you have a virtual environment set up with its own dependencies in that directory, it's always named venv. I follow that convention. I kind of like it. It keeps things simple, because what organizes everything for me is the name of the directory I'm working in. I know what I'm working on because of this name. I don't need the virtual environment name to point me to that. Also, by typing source, the name of the virtual environment, which in this case is venv, bin, and then the activate shell program or whatever it is in there. And that would do that. And then you would just type deactivate to get rid of it. And obviously I aliased a venv, and deemv is going to deactivate this when we're done. So now that we have a virtual environment and it's activated, we're going to take a look at what's in the token counter file. And you would use, we could use the GNOME text editor or Vim, whatever, Nano, whatever you like to use. And so this is the file. I'm going to close some of these others down because that's accumulated from a bunch of other videos that we've done. This is the Python file. This is the Python script. This is your shebang, hashbang, whatever you want to call it. This is your shebang header. That it's just something you need in there. I'm not here to teach Python. I'm just going to walk through this script real quick. We have to import tick token, which is an OpenAI library. We have to import system, sys, and we have to import argparse to write this script. So this is the function that counts the tokens, and it's just using a bunch of stuff from OpenAI. It's a GPT-4 or GPT tokenizer. Tokenizes it, and it does actually, I believe, tokenize it. And then we're just running the length function on the tokenized content. And then we just, somewhere we end up dumping it out. We don't really care to have it tokenized. We're not the LLM. We don't need it. We're just tokenizing real fast in ChatGPT's, in the GPT format of tokenization, so that we can count the tokens. That's all that's happening. And then in the main body or the main function, the argparse here, the parser, this just takes in the description. It counts the tokens given in the text that we pass it. And this is when we pass it in line. And we have to account for two ways of this tool to take in any kind of arguments or text. Inline is the argparse argument, and then after making that parser, a bunch of other stuff happens. We don't need to go, like I said, I'm not here to teach you Python. And then in this conditional, it just checks if there's inline text, and if there's not, it defaults to taking in from standard in, which means from the terminal. With, dumping, which is this is what happens, or this is what takes care of piping to this tiny little tool we're making. This section here takes care of passing text directly to the tool, meaning you type the command token counter, and then within quotes, anything you pass into it text-wise, it's going to tokenize it and count. It's going to take that in as an argument and then run it through the token counter function. And here, if it doesn't detect any text being passed to it that way, then it's going to be set to take in from standard in, meaning this is what takes care of piping to it. And then if it doesn't detect either means of receiving text, it'll just say, what are you doing, and kick us out. So that's what this Python script and token counter file does. Now we're going to be building this with Shiv, which requires this setup py file. So there's a couple things that we have to do. Now that we've activated our virtual environment, we have to pip install a few things. We have to pip install tick token, argparse, and we need to import Shiv. We need to install Shiv. All of that went well. And so now Shiv, real quick, when we go to run the Shiv command, Shiv requires this setup.py file. And so what that looks like, it's pretty simple itself. Very, very simple. And this is a process for using Shiv to make a standalone executable, meaning in this case, it's going to be a single Python file turned into a single executable with its dependencies bundled in with it so that it can be run as a standalone executable. It won't need any Python virtual environments to manage dependencies. The dependencies are going to be, bundled right in with it. And you could take this and put it on any Linux system. If you build this, you can put it on any of your other computers with a thumb drive or with a sync thing or whatever you use to share files, a Samba server, whatever. It doesn't matter. You won't have to set up any virtual environments or dependencies to run this tool. It'll be just like any other system tool. And especially after being inserted into our path, it will definitely be called up like any other system tool. And you'll see how that works here real quick. So in this setup file, this is just the standard format for what we're doing here. This gets a lot more complex when you're building a standalone executable in Python that has a ton of different files, modules, and all kinds of stuff. That's what the setup tool is trying to organize. It's a little overkill for one Python file, but it's how Shiv wants to build this tool. So you would just follow this format right here. You would put this into your setup tool or to your setup py file with setup tools from setup tools, importing setup, and setup tools is part of the standard library, so you don't really have to worry about importing that. And this just goes through the dependencies and this is a setup file for Shiv to bundle everything together. That's all it is. And so having that taken care of, we are going to need to run this command right here using Shiv, which is Shiv with the C flag switch token counter is going to be the name of the tool. Once it's built, we're passing it the token counter.py. Getting into this, we've made our virtual environment. We've looked at our token counter.py file, and this is what it would look like starting from scratch, having all of this in here, because what you would normally need to do, you want to see when you run an EZA for your ls command, you want to see this made executable, and this should be green. So what you would type is chmod plus x. Now I see that's made executable. So the command that we want to run is this guy right here, the -shiv-c token counter. This is a name used in the setup py file. We're going to name the executable that this shiv command is going to make token counter.pyz. This could be any number of things. We could make this also a hyphen, and then at the end, the dot just means in this directory. All the Python files in this directory, which we have to do the dot so that we include the setup.py. So we would run this, and we'll take a look, and now we have a build directory, token counter, aginfo directory, and now we have the token counter.pyz. It's made executable already. And now we can do something with this. We can take this thing right here. We can rename it. We can move, we do whatever we want. One of the things we can do right now is move it, meaning renaming it, because we're not going to a different directory. So now we just renamed it, got rid of the .pyz. And let's say we want to move it. We can run an alias to it. We can do any number of things, but let's just move it back to our bin directory. So to do that, we would just move the token counter to the parent directory. So now it's gone out of here, and we see we just moved it back. And right here it is now in our bin directory, .local bin directory. So now this can be called upon system-wide. We can call on this no matter where we are in our system. And I love Ranger for looking at these things, because we were in this directory here where we built it, and we just moved it back one to the bin directory that our .profile finds and inserts into our path when we start up every shell session. And after that's built, we can go in here, we can delete this, and dropping in, so everything we have, we could technically delete this whole directory. We don't need it anymore. We can certainly shut off the virtual environment. You would type deactivate, and that'll shut off the virtual environment, and I have it alias to dvmv. You can see that shuts off the virtual environment. We don't need any of these files now that we've walked through this. I have no reason to keep any of these files, but I'll leave them just in case. So now that we have the token counter inserted into .local bin, we can just cd back to our home directory where we have any number of things that we can do anywhere. Now we have a token counter tool in our terminal with us always now that we've built that, and we can go right back and test that out. So if we were to run fabric-y and we come over here to Daniel Miessler's YouTube video, put in the URL, and pipe that to our token counter. Type the name right. And we are right back after destroying, we burned our token counter tool, the one that I had built before the video. We burned it, we rebuilt it from scratch, and we're getting the same exact results using a GPT counter method. So we're right back to where we were at the beginning of the video, but having walked through building this tool for yourself if you want it. I'm sure there's plenty of other methods. Just if you build it like this, you just have the tool with you. It's nice and easy. It's not precisely accurate if you're using a variety of different types of models, but it's close enough. At 4840 tokens using the GPT method, this might be 4,900 or even 5,000 tokens with llama models, maybe a little less than 5,000, but it's right around there with llama models. It's pretty dang close for what we're doing, because now we can use this. We know that we're at 4840, and if we send this again, if we send this to the Fabric tool using the dry run, what we're going to be sending, so the dry run keeps this from actually running, we know that we're sending at least 10,500 tokens to the LLM, and we know that the default context window is not large enough for that. I'm telling you that I know from somewhere that I had researched, and I'll find it. When I find it, I'll post it in the comments maybe, but we're at 8,000 plus tokens. And so we know, having this tool on our system now, having this token counter on our system, we know that we have to run, when we run this right here, we would have to run this. We could actually set this to 12,000 and it should cover it. That allows for 2,500 tokens for the extract wisdom pattern response. And we're getting the expected type of extract wisdom response. 12,000 seems to do it. And we don't have to waste any compute or anything like that by going way, way over with wild guesses of 16 or 32,000. Having this token counter tool, we know about what we're going to need. And we can actually dial this in even a little more. Just dial in our knowledge anyhow. Let's say we take this extract, which it's a fairly well done response. And let's just copy that. And now that we have it copied, we know that we can use our PB paste tool. That's going to pull into PB paste via Xclip under the hood everything that we just copied to the clipboard, and we should be able to run this. And so our response right here from our command that we ran, the extract wisdom with the model context length of 12,000, this fairly good response is 580 tokens. So if we know we're sending approximately 10,500, we could add 600 onto that with just a little more. We probably could get away and get a good response. We could probably get away with setting our model context length to 11,000 tokens and still have room for a good response, enough window for the LLM to do its job well. And as we get down even lower than 11,000, we're going to start cutting into the LLM's ability to respond with a high quality response. As you can see, it still does well. As we start going down further and further, the response is going to degrade because we're going to be basically snipping off the Fabric pattern extract wisdom. So one last thing that I want to do with you guys here is this token counter. Maybe we just want to be able to type TC, right? Well, and we don't want to do that because TC is the name of an existing tool. So maybe we want to put in TCount or any smaller, easier to type thing. We can do that via, and I say via when I have aliased via to open the bash aliases file in Vim. But we could go right in here. We go down to the end of this file or anywhere we want. We'll look for a good place to put this thing. Let's say we put it right near Miessler Fabric related aliases, right? That's actually as good a place as any to put it. So we'll do TCNT for TCount for the token counter, restart our shell and try out TCNT. And now we have the token counter working with the TCNT alias. Now there is yet one more way that we can do this. We're going to go in and remove, or we'll at least comment out that alias so that it doesn't work anymore after we restart our bash terminal session. So what we can do is we can go into the .local bin directory where the token counter is, and we can actually rename that to TCNT. Now the token counter tool is gone. It's not actually gone. It's just renamed the standalone executable written in Python. Standalone, no dependencies, virtual environments, nothing to worry about. You can transport this file around, give it to everyone on earth. It doesn't matter. Anyone that might want it, whatever. And now in our bin directory, it's been renamed to TCNT. and it works. Voila. Now you have, if you set this up yourself, you have the means of always knowing very, very quickly about how many tokens you need your context window to be able to handle. Meaning a context window is everything you send in the payload plus the size that you expect the response to be. And so I would recommend that with a good extract wisdom pattern response from a decent LLM, I personally think you should account for a minimum of 1,000 tokens. And if you start running it with, say, GPTs, OpenAI, and your OpenAI keys, I would say allow for 1,500 to 2,000 tokens. That should always be more than enough for the most elaborate of extract wisdom pattern responses from an LLM. 1,500, 2,000, just, it doesn't hurt. And the thing is, with OpenAI, you can't control the context window anyhow. You can only control the context window with Ollama models. I'm pretty positive about that. You don't have the means to restrict or expand the context of OpenAI models. It's only the local models that you can control those windows. And so that being said, I would always take the token count of what you're going to send to the LLM via the Fabric whatever dry run, and then you pipe that to our token counter, and that will give you the tokens that you know that you're going to be sending in the LLM payload. We'll just do a real example here. That'll send about 68 tokens, and then whatever we expect the response to be, which with this one, let's guess somewhere around 500 or 600 tokens. And so with something very, very small like this, we don't even worry because we know we have a context window default of 8,000 plus tokens. But when you start getting some long things here, like if we take another one of Miesler's videos, anything that we know that's a half hour or so, we know that we're probably going to have to increase the context window for that command because the Fabric tool is sending the transcript body twice. Now, the thing is, maybe they're doing that on purpose for some reason that I don't know or that I don't understand. And if that's true, Mr. Miesler, I apologize up and down. But that's how you get around this problem. When you start getting crap or garbage responses from things like extract wisdom, it's because I believe the system message, the extract wisdom pattern, is being ejected because we've gone over the context window limits. So I hope this was helpful to somebody. I know it's going to be helpful to a few of the people that I'm teaching these things to that live directly around me. Hopefully